In this video, let's go through a quick introduction of Kubernetes architecture. If you are new to the Kubernetes technology, suppose you may heard about some terms like master node, worker node, and node port, so on. So I'm going to explain each component and what is master node and what is worker node throughout this video. So let's understand the master node and worker node components in the Kubernetes. First of all, we have to understand that Kubernetes have two planes. One is control plane and another one is data plane or compute plane. So this one is control plane. Control plane includes master nodes. It may be one master node or two master node or more than that. And the data plane or compute plane includes worker nodes. Likewise, work nodes may be one or two or more than two. The count of nodes is purely depends upon our project or our application requirement. So don't confuse with these terms like master node and worker node or control plane or data plane. So if anyone don't know what is node and if you are not aware about node, don't worry. Node is nothing but node is just a server or virtual machines. The server may be on-prem or cloud, whatever. So throughout this video, if I say like master node means just understand like master node is a server and worker node is another server. Without any delay, let's dive into the components in the Kubernetes. So this diagram I downloaded from the official Kubernetes document. You can also refer from there. If you look into the master node has some components like scheduler, API server, etcd, controller manager. Likewise, worker node have some components like kubelets, kube proxy or service proxy, and pod, container runtime environment, so on. So don't worry, I'm going to redraw this diagram to understand easily. As I mentioned before, I'm going to redraw the Kubernetes architecture here so you guys can easily understand the architecture of Kubernetes and what are the different components of Kubernetes. Before that, I'm going to talk about the Kubernetes. Actually, Kubernetes is an orchestration platform. Orchestration platform means we all are following microservices architecture for our application development. While we follow the microservices, definitely there will be a bunch of microservices. It depends upon our application. It may be 100 or more than 100. So each service or each application services we will dockerize and we will run as a Docker container. Is right. So we will run our application services as a Docker container. So definitely our application will have 100 or more than 100 Docker containers. We know our application services we will develop as a Docker container. We will dockerize and we will run as a Docker container. So our application might have a bunch of Docker containers. Maybe it may be depends on our application, like it may be 100 or more than 100, even more than 500. So manage and control all these Docker container by manual is a tedious process and very headache. So we will use orchestration platform like Kubernetes to manage and control all these Docker containers. Kubernetes is a orchestration tool. It's a orchestration platform. So we will deploy all these Docker containers inside the Kubernetes. So Kubernetes will manage and control all these Docker containers as auto healing, auto scaling, everything will managed by Kubernetes. So just understand the development process in your mind. So I'm going to redraw the architecture of Kubernetes. I'm going to delete all this one. We know that in Kubernetes architecture we have seen a control plane or master node. This is our control plane and master node. Next I'm going to draw the worker nodes or data plane. So the data plane here is consist two worker nodes. This is second worker node. Okay. So this is our compute plane or worker nodes, and this is our control plane or master nodes. Okay, right. The overall architecture of the Kubernetes is known as cluster. So you might hear the word cluster. So this is our Kubernetes cluster. The overall master node and worker node architecture is known as cluster. And next we know that inside the master node there will be a API server. Actually API server means it's a entry point or gateway into the cluster. So as a user or as a DevOps administrator, we can communicate with our cluster through API server via command line or API or any UI. So the command line, we have a command line tool that is kubectl. So this is API server, and inside the master node there will be a etcd. Actually etcd is a storeroom or a database inside the cluster. The overall configuration and the state of the cluster, everything will be stored inside the etcd as a key value pair. So inside the master node or control plane there will be a etcd component. And next is scheduler. Actually scheduler means if our API server receives any request from a user or administrator, like want to deploy any pods or Docker container, the scheduler will decides on which worker node that pod want to deploy. So the scheduler actually will schedule everything. And next there will be a controller manager, and the etcd will communicate with the API server. Likewise scheduler will communicate with API server. Also the controller manager will communicate with API server. Fine. The controller manager actually will control the actual state and desired state of the pods inside the cluster. So next let's look into the worker node components. And we know our Docker containers will be deployed or will be inside the worker node. So that to run the Docker containers, first we need a Docker runtime environment. So inside each worker node there will be a container runtime environment. Okay, so that will be available in each worker node. And inside the inside the container runtime environment there will be a pod. This is pod. Actually pod is a smallest unit in the Kubernetes architecture. Pod is a abstraction layer over the Docker containers. So inside the pod where we will deploy the Docker containers. Fine. We will deploy our Docker containers inside the pod. So there will be multiple containers inside the worker node inside each pod. Okay, sorry. Like this we will deploy. So the setup will be here also. We will deploy our applications Docker containers or our application services inside the pod. Okay, and there will be a kube proxy component, and another one is kubelet component. So these components will be available in each worker node. So it will be available here also. As you know, in our Kubernetes cluster, we created one master node and two worker node. So the count of nodes will be depends upon our application or project requirement. For our demo purpose, I just demonstrated here is with one master node and two worker node. The count of nodes will be depends upon our project requirement or our application availability. So to ensure the high availability of our application, sometimes or some specific project or specific application, we will use 3 or 2 master nodes and 3 or 4 worker nodes. So everything will be depends upon our application or project requirement. This kube proxy and everything will communicate with our API server. And here we can see two agents, kubeproxy and kubelet. Actually kubelet will ensure the pod health, everything is running and everything is okay or not, everything will check by kubelet agent. And the kubeproxy in the Kubernetes cluster is responsible for network communication between two nodes and node and master node, worker node and master node communication. Everything will be ensured by kubeproxy component. So this is the overall Kubernetes architecture and the components inside the master node and worker node. And here you can see API server is a entry point to KH cluster, and control manager keeps track of what happening inside the cluster. Like it will control the desired state and the actual state of the replica count and replicas, and the scheduler it ensures the ports placement that I mentioned earlier. If a API server receives any request or something or any new port deployment, the scheduler will actually decides where they want to deploy on which node or which worker node it want to deploy, and everything will schedule by the scheduler. etcd is a Kubernetes backing store. It's act like a database inside the Kubernetes cluster, and the values will be stored in the form of key value pairs. And here you can see the node versus pod. Node is a server or virtual machine. Pod is the smallest unit in the Kubernetes, which gives an abstraction over Docker container. I clearly explained that point. And the control plane components, we know that kube API server, kube scheduler, kube control manager, etcd. And we know the worker node components like container runtime environment, kubelet, kubeproxy, and these are the worker node components. I hope you guys got the clear idea about the Kubernetes architecture and about the Kubernetes components.